Okay, so the next problem in the lead code we are solving is kth smallest element in the binary search tree. Okay, so basically here we have given a binary search tree and we'll have to find out the kth smallest element. So meaning, so let's say if this is a binary search tree. Okay, so let's say that if we sort it, okay, once again, if we pick all these elements and if we sorted in ascending order, right? Let's say that 1 2 3. Okay, k is equal to 1 2 3. Okay, like I mean these are the index. Okay, there are some numbers here, x y z. Okay, and what they are asking is k smallest element. It means that if k is equal to 2, this is the smallest element that we are going to get, right? So to what does it mean? Like basically if we rearrange all this binary search tree and write in one array, and with index 1 2 3, and we are being asked to return the kth smallest element. If it's the kth largest element, we would have come from the end. Okay, let's say that this was the end, right? And if you are asked from a kth largest, I mean last second largest or whatever it is, right? If it was one, we would have written this one, or else we would have written this one, right? So now how to approach this problem, right? So basically what we need here is to identify if it is a case smallest, we need the element in a sorted order. Okay, so how are we going to get a sorted order? So basically we know that one principle, right? Like I mean ideally what is the principle of this binary search tree? Whatever this is the root, and this will be the left, and this will be the right, correct? This will be the root. Okay, so always what is the condition that binary search tree follows is left will be lesser than the root, lesser than the right. This is root. Okay, so this is the condition that follows. Okay, and also by looking at this, like if you are able to build a tree in this order, right, then we could have easily analyze this value, correct? Like I mean basically what will happen is, as we can see here, right, this is the left and this is the root and this is the right. We can easily, I mean we can see one pattern that how are we going to traverse, right? Like I mean this is nothing but an in-order traversal, right? Like I mean how we need to decide which traversal mechanism to use, like to build this array, right? So we can convert this tree into an array. Which traversal to use? Like I mean it's as it says left root right, it's nothing but an in-order traversal. Okay, and also one key thing to note here is, like once you sort this array, right? So once you sort this array, like you will be getting a sorted order. Okay, that's a straightforward thing. So let's say that if you traverse it, right, so first we'll go to one here, one, and then we'll go to root 3, and then we'll go here, but we should be processing left first, so we'll go here and then this, so it should be like 1 3 4 6 7, and finally we'll go to the root here 1 3 4 6 7 8, and we'll be doing the same thing here 10 13 14. Okay, so ultimately we'll be getting the list. So if you are able to traverse the binary search tree using an in order, right, you will getting a sorted order. Okay, this is one key takeaway from this problem. Okay, so whenever we convert this binary search tree using a in-order traversal, that will be sorted. So now they are asked to return as a k is equal to 2 or 3, right? Like I mean the smallest element, k smallest element. So we can just return the index of it, like I mean whatever it is, right? Like index is 1 here, basically one indexed, so we can just minus 1, right? So if k is asked 1, we can return a zeroth index, or if k is asked to 1, we can return 1 index. Okay, so and okay, this is the one thing to just to summarize here. Binary search tree can be represented in a if you traverse in a in-order pattern, we'll be getting a sorted array. Okay, this is one thing, and we can get on the basis of that we can extract the k smallest element. Okay, so now do we really need to, let's say that if they are asked k is equal to 2, correct, k is equal to 2, but is it really necessary to build the full list, right? We don't need to convert this full tree into the like I mean list, right? Again it will have some space complexity. So what we can do is we can keep track of some variable. Okay, so when we say in order, it's nothing but a dfs, right? So we'll be using a recursion there, and whenever we found a result, like I mean we'll keep a track of some variables. Like let's say that we'll initialize this k value to initially to 0, and whenever we found some element, we'll increment that, and this will be a global variable. Okay, and finally when we reach that k value, right, answered, we'll set the answer and we'll exit off all the recursion. Okay, so that's how, like I mean we don't have to build the full list, like I mean the traverse list. We can simply keep a track of some variable and exit it, so that we can save some memory. Okay, so let's see the implementation. So what we have done is currently we have initialized the case equal to 0, and we will be tracking the result with this flag, result found is equal to not. Okay, none. So once this is result is found, right, like when we are doing the recursion, we will be returning it. Okay, and every time, like I mean, okay, that's not the answer. Okay, once we get the result, we'll be returning it here, and every time when we start, right, when we start, and if we don't find any result, we'll just return it. We don't do anything. Okay, we'll come out of all the recursions. Okay, so now what will happen here is, so we've initialized to current value to 0, current case 0, and result found is none. Okay, we didn't find the result. So now we'll start the in-order traversal. What we are going to do, we'll go to the left, and then we'll analyze the root, and then we'll go to the right side part of the tree. Okay, so this is it. So like whenever we are traversing, we'll be incrementing the k, and then once we match the index, right, in the index is matched, right, we have declared this as a non-local. So once that matches with the given asked k, so we'll set the result. So once we set the result, none of the recursion will run, it will just come out of everything, and finally we will be returning that global variable result found. Yeah, that's it. So the key takeaway here is binary search tree, if you represent in a in order manner, so it will give us a sorted output. If they, like I mean, they might also ask the kth largest element, or like I mean last, like in that case what we could have done is, like in order traversal is necessary, we could have like I mean, return the last, the second element, third element, we could do that. Okay, yeah.